The bitter side of sweet, aspartame's potential link to heart disease and insulin resistance. Introduction. Aspartame is one of the most commonly used artificial sweeteners in the world. Found in thousands of sugar-free and low-calorie products, from sodas and chewing gum to yogurts and desserts, it has long been marketed as a safe alternative to sugar. But new research is calling that assumption into question. A recent study published in Cell Metabolism suggests that aspartame may not be as harmless as once believed. Instead of simply being an inert, no-calorie substitute, aspartame may actually interfere with insulin signaling and contribute to inflammation in the blood vessels, potentially increasing the risk of cardiovascular disease. In this episode, we examine the findings of this new study, explore how aspartame may affect the body, and consider what this might mean for anyone trying to manage blood sugar, protect their heart, or make more informed dietary decisions. For years, aspartame has been positioned as a healthier alternative to sugar. It is hundreds of times sweeter than sucrose, so only a small amount is needed to sweeten foods and drinks. This has made it popular among people watching their weight or trying to manage diabetes. But the promise of sweetness without consequences may not hold up under closer scrutiny. In the recent animal study that has sparked widespread concern, researchers fed mice a diet containing a moderate amount of aspartame, roughly equivalent to what a human might consume by drinking 2 to 3 cans of diet soda a day. Over a 12-week period, these mice developed elevated levels of insulin, increased fat accumulation in the arteries, and higher markers of inflammation in the blood vessels. This combination of symptoms resembles the early stages of insulin resistance and atherosclerosis, two key contributors to heart disease. What makes these findings particularly troubling is that the insulin levels remained elevated even after meals, indicating that the body was being pushed into a prolonged state of high insulin output. Chronically high insulin levels can wear out the pancreas, lead to systemic inflammation, and eventually create a resistance to insulin's effects. This condition, known as insulin resistance, is a major precursor to type 2 diabetes and is also associated with obesity, high blood pressure, and metabolic syndrome. The researchers discovered that aspartame appears to activate certain neural pathways that stimulate the release of insulin from the pancreas. This means that aspartame may trick the body into thinking it's about to receive sugar, prompting an insulin response even when no glucose is present. Over time, this repeated activation can desensitize insulin receptors and impair glucose metabolism, setting the stage for metabolic dysfunction. In addition to the hormonal effects, the study found that aspartame increased the production of a signaling molecule in the endothelial cells that line the blood vessels. This molecule, called CX3-CL1, interacts with immune cells and plays a role in vascular inflammation. When CX3-CL1 is upregulated, it attracts white blood cells to the arteries, which can contribute to plaque formation and the thickening of arterial walls. Over time, this kind of low-grade inflammation can increase the risk of heart attacks and strokes. Although this study was conducted on mice, the findings raise significant concerns for human health. Animal models are often used to explore physiological mechanisms because they allow for controlled experiments that would be difficult or unethical to conduct in humans. While we cannot assume a one-to-one translation of these effects to people, the biological pathways involved, particularly insulin signaling and vascular inflammation, are highly conserved between species. That means the mechanisms observed in mice are likely relevant to human biology. It's important to understand that aspartame is just one of many artificial sweeteners on the market. Others include sucralose, saccharin, acesulfame potassium, and newer sugar alcohols like erythritol. Each has a slightly different chemical structure and mechanism of action, but all aim to reduce calorie intake by providing sweetness without sugar. Yet recent studies are beginning to challenge the assumption that artificial sweeteners are biologically inert. Some appear to disrupt the gut microbiome, while others may influence hunger hormones or alter glucose metabolism in ways we're only beginning to understand. In the case of aspartame, regulatory agencies such as the FDA and EFSA continue to regard it as safe when consumed within established daily intake limits. However, emerging research is revealing a more nuanced picture. Safety assessments have historically focused on cancer risk or short-term toxicity, not on long-term metabolic or cardiovascular effects. As our understanding of the body's response to artificial ingredients evolves, it becomes increasingly important to update public health guidelines and dietary recommendations accordingly. So, what can individuals do with this information? For those already living with insulin resistance, type 2 diabetes, or cardiovascular concerns, reducing or eliminating aspartame may be a prudent step. Even for those who are generally healthy, choosing more whole food sources of sweetness, such as fruit, dates, or small amounts of raw honey, can help reduce reliance on processed additives. Plant-based sweeteners like stevia or monk fruit, though also processed, appear to have less impact on insulin signaling, though more research is needed to fully assess their safety profiles as well. Another important strategy is to shift from thinking about individual ingredients in isolation to looking at the overall pattern of food consumption. Artificial sweeteners are often found in processed packaged foods that contain other additives, preservatives, and ultra-refined ingredients. By choosing real, unprocessed foods and making meals at home when possible, we reduce not just our exposure to aspartame, but also to the many hidden substances that may be contributing to chronic disease. For those who drink diet sodas regularly, it may be worth experimenting with alternatives. Carbonated water flavored with citrus, herbal teas, or homemade infusions with mint and cucumber can satisfy the desire for something refreshing without compromising metabolic health. The goal isn't to create a new rule to follow, but to bring awareness to how these choices impact the body over time. It's also crucial to acknowledge that changes don't need to happen overnight. Simply becoming aware of the ingredients in common products, reading labels more carefully, and making small adjustments can add up to meaningful improvements. If research continues to support the idea that aspartame interferes with insulin regulation and promotes inflammation, then reducing its intake now may offer long-term protection, even if we don't eliminate it completely. The broader conversation here is about how we define health-promoting choices, not based solely on calories or sugar content, but on how foods and ingredients interact with the body's delicate hormonal, vascular, and neurological systems. When we choose foods that support, rather than confuse these systems, we not only protect against disease, but also support greater energy, clarity, and overall well-being. Conclusion: aspartame has long been marketed as a safer, lighter alternative to sugar, especially for those managing weight or blood sugar. But new research is revealing a more complex picture, one where this sweetener may be silently influencing key systems in the body, from insulin regulation to blood vessel health. While more human research is needed, the biological mechanisms uncovered in animal studies should not be ignored. For anyone focused on long-term wellness, reducing reliance on artificial sweeteners and embracing whole, unprocessed foods may offer a safer and more supportive path forward. Health isn't just about what we subtract, it's about what we choose to nourish ourselves with instead.